you're watching from. I just want to say thank you for actually commenting on our posts, sharing our posts, and also subscribing. Without you, we can't actually be. So today again, we're going into another phase, and that is in chemistry. And today, I'll be taking you on the radicals. Okay, just follow up and watch. Thank you. Now, probably might be asking what is radical or what are radicals? Radicals are actually a group of atoms of an element or two or more elements that has a charge, and that charge can either be a positive charge or a negative charge, and that is what we call the cation ion. That's positive, and we have the negative. That's the anion. That's negative. So it's either a group of atoms is actually having a charge, and this charge actually distinguishes this element from the other elements. And with the help of these radicals, it will help us to actually understand the concept of IUPAC nomenclature, okay, of elements, trying to combine one or two elements together to have a compound, and how to actually get their bonds, the only bonds actually involved in it. So that's one of the importance of this radical. So an example of the radicals, that's examples. We have the CO3 2 minus. We have the OH minus. We have the NO2 minus. We have minus. So these are the negative or the radicals rather. So now we have, and also we can also have them as either monovalent or polyvalent. Okay, so for the cation ions, the monovalent, mono means one. Okay, valent, talking about their valency, monovalent charges. That we have chlorine. We have fluorine. We have bromine. Okay, we have bromine. Because of time, I will not actually list them. Then we have the divalent charges. That's having two charges. We have the barium. We have barium 2 plus. We have cobalt 2 plus. We have copper 2 plus. We have magnesium 2 plus. We have magnesium 2 plus. We have calcium 2 plus, etc. And also we have here, let me add a negative, a positive one. We have sodium as well plus. Okay, so I'll also advise you find time to go into the radicals and also charges of some known elements. Although some of them too are trivalent, like the trivalent electrons, the trivalent ones, elements that have the charges. We have chromium having 3 plus. We have aluminium having 3 plus. Okay, and also we have even here too we have lead 2, and also lead 2. We have zinc. We have tin. Also we have those that have the tetravalent. That's 4 tetravalent charges. We have lead 4. Okay, having a charge, etc. So because of time, I'll stop here. So probably I would advise you You get your books down and get these charges. When you know these charges, it will actually help you to balance equations. It will actually help you to name inorganic compounds, okay? So that's for it now. So we're going to questions. Okay, so this will lead us now into oxidation number. Okay? Oxidation number. And I know we've heard of this word, oxidation number. It's otherwise called the oxidation state of an element or a compound, okay? Now, oxidation number simply helps us to identify a charge that is actually unique or related to that particular element or compound. So with the help of this radical, so we can know how to solve questions on oxidation number. You can otherwise write it as ON, okay? So there are rules assigned. Rules assigned. Now, if you want to actually know how to solve oxidation number, these rules are actually applicable for you to solve them very well. Now, the first rule is this. The oxidation number, that's ON, of an atom in an uncombined free element is 0, whether as a molecule polyatom, whether as a molecule, as a noble gas, etc. That as a molecule, that we have hydrogen molecule, oxygen molecule, we have nitrogen molecule, etc. Now whether as a noble gas, we have helium, we have argon, we have neon, etc. Okay? Or whether as an element, for instance, we have sodium, we have what's it called, magnesium, whether as aluminium, etc. Okay, so what it means is this: the oxidation number of an atom in an uncombined element is 0. And that's to say, if you're asked, you say question 1, what is the oxidation number of, let me say, sodium? Okay, so the oxidation number of sodium is, answer, let me say solution, is just what? The ON, that's the oxidation number of sodium, that's Na, is what? Equal to 0. So that's what it means, okay? Is equal to 0. So this is rule number 1. Then rule number 2 says the oxidation number, that's ON, of oxygen in its binary compound is -2, take note, except in peroxides, where it is -1. An example of the peroxide, examples of peroxide is, we have hydrogen peroxide, H2O2, we have sodium 2O2. Okay, so that's rule number 2. Then rule number 3 said that the oxidation number of an atom of hydrogen is +1, plus 1, except in the hydride of metal, where it is minus 1. An example of the hydride, example of metallic hydride is single right here, sodium hydride, and where it is what? Minus 1. Okay, so that's rule number 3. Then rule number 4. Rule number 4 is this. Rule number 4 is this. Then rule number 4 is this. Rule number 4 says the oxidation number, so I'll just have to shorten it. The oxidation number of a radical is equal to the charge, equal to the charge of the radical. Let me see. For instance, okay, we have SO4 2 minus. Now when you're asked what's the charge, what it simply means is this: the charge is equal to SO4 2 is equal to minus 2. So this is the charge, okay, of this radical. And also the oxidation number of a compound is equal to 0. Let me say, for instance, for example, in this compound, the oxidation number is equal to 0. Okay, that's what it means. That is C is equal to 0. Okay, so when you note this rules, it will not help us to solve the questions which I'm going to actually outline here. Okay, so with this, let's solve one question. Okay. Okay. So let me see. Question 1. Find the oxidation number. Find the oxidation number of copper. Okay, copper in this compound. Okay. So we are asked to find the oxidation number of copper in this compound. So what do? So our rule, what rule is that? Rule 5 says the oxidation number of a compound is equal to 0. For example, in this equation, so let's take this as a compound to solve. So the oxidation number of copper in this compound. So we say let S represent, that's rep the oxidation number of copper, because we're looking for copper. Okay, so let this X represent it. Okay, so it means, and please don't forget this this 2 here, that is the subscript, simply means the atomicity of copper here. So the atomicity of copper here is 2, okay, and the atomicity of oxygen here is 1. There's an invisible 1 here. Though it's not written out, okay, but we just, as we know, it's actually there. So what do we do? And we say let S represent the oxidation number of copper, okay? So what do? We apply this mathematically. 2 will come into X, that's representing copper, okay? Plus, so we know there is 1 here, we say 1 into brackets. Now for oxygen, if you remember rule 3, that's rule 2, that says that oxygen, okay, oxygen in a combined state is minus what? 2, except in peroxide. So in this case now, oxygen is going to be what? Minus 2. And what is going to be? It's going to be what? Equal to 0 based on rule 5. Based on rule 5, okay, is equal to 0, okay? So what do we do next? Probably have to solve. Please follow on, just follow, okay? Going to solve. So we open up the bracket. 2 times x is what? 2x. Now, please, before you bring up your plus sign here, note that there's a minus sign in this bracket, and we have to open up the bracket. So minus times plus, or plus times minus is equal to what? Minus. So 1 times this will give us minus 2 is equal to 0. So we have 2x. When this minus 2 crosses over to with 0, becomes 0 plus 2. So we have 2x is equal to 2. And what do? We divide both sides. By 2 to obtain s. So we have 2x over 2 is equal to 2 over 2. And after, what do next? We divide both sides. So 2 here, 2 here, 2 here, 1. So x is equal to plus 1. Please don't just write ordinary 1. You have to indicate it, because I said a radical actually what? Is carrying a charge. So therefore, the oxidation number of copper is what? Plus 1. Okay, so that's our answer. So I think I'm going to solve one question. I'm going to add one question. So then I'll give you a work to solve. Let me see, you're going to put that in the comment section below. You're going to find question 2. Says find the oxidation number. The oxidation number of phosphorus. In phosphine. That is pH3. Okay. So this is a question. It says find the oxidation number of phosphorus in phosphine. So solution. What do? First of all, we say you can use any variable to represent. You can say, okay, let y represent the oxidation number of phosphorus. Okay. Phosphorus. So we write the application. So that's pH3 is equals to what? And please take note again when solving. Take note of the atomicity. The atomicity of phosphorus here is 1. The atomicity of hydrogen here is 3. Okay. So we have, let me just say 1 into y plus 1 into y. That's let y represent the oxidation number of phosphorus. We have 3 here. That's the atomicity of hydrogen here. And we said the oxidation number of hydrogen is what? Plus 1, okay? Except in sodium hydride or in the hydride of metals, okay? So we have plus 1. Just write 1. And it's equal to what? 0 based on our rule. I think the rule 5 that says when you have a compound, the atomic oxidation number of it is equal to 0. So we have 1 times y is y plus 3 times 1 is 3 is equal to 0. So our y is equal to, when this 3 meets this one here, there will be a negative sign. The negative sign will turn to, the positive sign will turn to a negative sign. So 0 minus 3 y is equal to what? Minus 3. So therefore, the oxidation number ON of phosphorus is what? Minus 3. Okay, so that's it. So we're going to stop here, but I'll give you a question to solve to see your or let me just solve one more question, although that was for radicals, okay? Let me just solve, then I'll give you a question to solve and try it out in the comment section. Just read. It says find the ON of x in x2 O7 2 minus, okay? So we are out to find the relation number of x. Now, the name of this element actually just x, okay, presented in this equation, okay? So in this compound. So we have to find the oscillation number of x. So solution. So we have x subscript 2 O7 2 minus. And from our rule, the rule says that whenever we have a radical, that compound is equal to the radical, okay, that covers the compound. So what do? x2 O7 is equal to minus 2. So you see it now. So this charge here is equal to, it's going to be equal to the whole compound here. So we said we don't know x, so we say let 2 into x, that's 2 into x plus 7 into minus 2, that's the oscillation number of oxygen here is what? Minus 2 is equal to, this is minus 2. So what we're going to open up the brackets now. So we have 2x minus, that's 2 times x is 2x plus 7 times minus 2 is going to be minus 14 is equal to minus 2. So what do? We sub 1. So this minus 14 will cross over, it's going to be minus 2 plus 14. So we have 2x is equal to 12. Okay, so we divide both sides. By 2, so we can get our x. So 2x over 2 is equals to 12 over 2. So I'll cancel this one. 2 here, 2 here, 6. So our x is equals to what? Plus 6. Please ensure you put this charge as either cat ion or what? Anion. Positively charged is what? Cat ion. Negatively charged is what? Anion. Okay. So the oscillation number, that's the ON of x atom in squared s superscript rho 7 2 minus is what? Plus 6. Okay, so we're going to stop here, but I'm going to give you a question to try out there. You send it to me on the comment section, and also maybe you can private chat me as well to send your answers. Let me give you the question, and that is this. Okay, please try it. Okay, just try it. So you know how better you are. Okay, that's fine. The oxidation number of iodine in this radical, and that is this iodine. Okay, so solve it. Use the question, solve it, and send your answers. So once again, I want to say thank you for your time. Thank you for actually subscribing. Thank you for watching and following us. And please, one thing, do not forget to share this video. Tell your friend about it. Comment where necessary, and please study as well. Thank you. God bless you for supporting EGC Educate Global Radicals. See you some other time. Bye for now. Okay.